guys, welcome back to another episode of A2 Chemistry, and today we are doing phenol. So this chapter is pretty short. There's a few things that you need to know, especially the first thing is how phenol is behaving as a weak acid. You need to know the explanation. So that's the first part. The second thing is the production of phenols. So you need to know how to get a phenol. So from a diazonium salt, you warm it, you get a phenol. Okay. So the next thing is the reaction of phenols. You have to memorize all the reactions for phenols. And next is going to be the diazotization reaction of phenols to produce an azo dye. That is a very popular question in exam. And last part is going to be the reactivity of phenol compared to a benzene. So basically, phenol is more reactive compared to a benzene, and you need to know the reason why. Okay, so that will be all, and please enjoy the video, copy down your notes. I'll see you guys soon. Wow. Cheers! Alright guys, first let's look at the property of phenol. Yeah. So what is a phenol, right? It's basically an alcohol attached on a benzene group. Okay, so you see this hydroxyl, okay, on the benzene group, that we call it as phenol. We don't call it as hydroxy. Okay, you don't call it as a hydroxy benzene, we just call it as a phenol. Okay guys, now let's look at phenol. What is the IMF present for phenol? You have OH, you have alcohol. So what is the most significant IMF? Hydrogen bonding. Remember, yeah? So you have OH, right? Which means hydrogen bonding is present, right? Okay, so guys, since hydrogen bonding is present, which means the IMF of phenol is pretty strong, yeah, compared to benzene. So let's look at the state. So phenol is not a solid, it's not a liquid, it's not a gas. Phenol is a solid, yeah. So highlight the word white crystalline solid. Okay, and guys, let's look at the solubility of phenol. So phenol, right, is not very soluble. So it's only partially soluble. Why? Okay, if you look at OH, right, this is the polar group. Hydrogen bonding is polar, right? Am I right? Which means this part is soluble. Understand? All right, guys, what about the ring itself then? The ring itself is polar or non-polar? So the ring itself is non-polar, right? Okay, so you have this non-polar ring, which make it not soluble, yeah, understand? So a phenol overall is just partially soluble, not very soluble, not highly soluble, but just partially. Okay, so on one reason, because you have a non-polar benzene ring here, okay, and a hydrogen bonding which is soluble. Okay, next, melting point of phenol is relatively high. Why? Because the presence of a hydrogen bonding, right? So you have a hydrogen bonding, right? Okay, between its molecule, so which is why the melting point is relatively higher. Okay, next, however, the large non-polar benzene ring makes phenol only slightly soluble in water, yeah. Okay, and as it disrupts the hydrogen bonding with water molecule. Okay, now let's look at phenol. So phenol itself, right, is a weak acid, yeah. Remember that, yeah. Phenol is a weak acid. So guys, if I take a phenol, numbers here. Okay, and if I add into a water, so phenol gonna dissociate partially, just partially, into O minus, which we call it as a phenoxide ion, and a H3O plus. So a phenol can dissociate in water to produce a H plus ion. Yeah? So once a H plus ion is produced, we call it as a phenoxide ion is formed. Phenoxide ion, okay? So a phenoxide ion is formed. That's it. So, sir, if there are more OH added, it will be more and more soluble. Yes, Tanvir, you are right. So if there's more OH present in a benzene ring, it's gonna be more and more soluble. Same thing, if you have more and more benzene ring attached, it's gonna be less and less soluble, okay? Because the non-polar part is more dominant now, okay? Good. So the position of equilibrium lies to the left-hand side. Phenol is a weak acid, then water. So with ethanol, blah, 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 blah. Okay, this part is kind of nonsense. It's okay. So I don't need you guys to point 0.5. I'll explain it later. Okay, then guys, we have something known as a pKa value, yeah? So guys, look at the pKa value. So I haven't really teach you guys about the pKa value yet. So what is pKa value, right? You just imagine and you read it as pH. Understand? So the moment you see the pKa, just read it as pH. Okay, so guys, now let's look at this. Okay, we have pKa at 25 degree, 10, 14, 16. So which one is the most acidic? Which value? 10, 14, 16, 10. Good job. So again, the lower the pKa is, you can just read it as the lower the pH. So this is the most acidic. Understand? Clear? So kid, I can say that, right? The lower the value of pKa, the stronger the acid. Because how you read your pKa, right, is just you read it like pH. Okay, so I'll talk about it later on. Okay, next, phenol can lose a hydrogen ion because phenoxide form is stabilized to some extent, blah, 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 blah. Okay, next, the phenoxide, 0.7, I'll talk about it later. So the phenoxide ion has a negative charge spread over the whole ion, as one of the lone pair will delocalize, will overlap with the delocalized pairing system. This point, I will talk about it later on. Yeah, so I think 0.8, 9, 10, we skip that first. I want you guys to look at page 2. Okay, so you skip 0.89 first. Let me explain it on the weak acid first. What page is this, baby? Page 1. We are at page 2. Page doer. Okay, now guys, the first thing is how phenol behave as a weak acid. So just imagine this is your phenol. Okay, so I'm gonna extend this line. No, that's Alright, guys, first, let's look at how a phenol acting as an acid. Guys, what is the definition of acid? It's a proton dissociate in water to produce a H plus, which means acid is always a proton donor. Remember, yeah, acid will always give out a H plus. So guys, how phenol gives out a H plus, yeah? Okay, so just imagine that. So you have oxygen, yeah, is group 6, correct? So let's look at it. You have 1, 2, 3, 4, 5, 6, correct? So these are all the electrons on oxygen. Okay, and guys, now what you need to imagine, yeah. Okay, so the story is, right, okay, you imagine all these electrons, okay, are kids. Remember this. Okay, so all the electrons are kids. Okay, then you have a ring, yeah. This benzene ring is a playground. Okay, so remember this, guys. This theory, right, or this concept, okay, we're going to apply it for chapter 27, 28, 29, 30. So remember this, when you see electrons, right, you have to visualize them as kids. They love going into the playground, which is the ring. Okay, so any lone pair that you found on any other group, okay, so this electron will always have a tendency to go into the ring. They love playing in the playground, understand? So again, I just want you guys to highlight all these lone pair, all the electrons here, all the electrons, right? Okay, so they love the playground. So electrons are like kids. So what they will do, right? They will move, or they will overlap, or they will delocalize into the playground. Understand? They will go into the playground. Okay, so one more time, yeah. So electrons, your lone pair, electrons on your oxygen, the lone pair, okay, love the playground. So they'll go into the ring. Understand? So the story started from your lone pair on your oxygen atom. Okay, so all these kids, right? So what they do? They delocalize into the ring, move into the ring. Understand? Understand? So again, you see, your lone pair on oxygen atom, the kids delocalize into the ring. Okay, so guys, when this happen, right, please tell me what happens to the OH bonding. Will this bonding be stronger or weaker now? Weaker, because again, this electron, right, go into the ring already, understand? So the OH bond right now is weakened, understand? So your OH bond is weakened now. Alright guys, when OH bond is weakened, what's gonna happen next? Do you see that it breaks? Understand? So right now, you see, this entire phenol will turn into a phenoxide ion. Hi, Kritika, we are at page 2 now, yeah? So please flip to page 2. Okay, so we'll turn into a O minus, get me? And a H plus is formed. Clear? Alright guys, now we are done talking about why phenol is able to act as an acid. Again, the entire story starts from, look at the story. You have all these kids, correct? What do? They go into the playground. Which means OH bond is weakened. H plus is released. Understand the story? Clear. Alright guys, next, you have to talk about why the formation of phenoxide ion is stable. So I want you guys to write somewhere here. Okay, so maybe you can put a line here. So I can put a point here. The formation of a phenoxide ion is stable, yeah. Why does OH bond weaken? Is it because difference in, no, it's not because of difference of electronegativity. It's just that the electrons go into the ring, what? You see me, you see this, the electron go into the ring. There's nothing here. When there's nothing means there's no bond already, you get me or not? One more time. What is a bond? A bond is when there is a pair of electron. But it's not, no, it's still electrons. Electrons are kids. They will still delocalize into the ring. Understand? Alright guys, next. Let's go. So formation of phenoxide ion is stable. Why is it stable? Reason, yeah, guys. Let's look at the negative charge. This negative charge, right, is due to you have all these lone pair. Am I right? So the lone pair on oxygen, okay, so this lone pair on oxygen gives the negative charge. But right now, what happens to a lone pair? As what I mentioned, these are all the kids. So when you have all these kids, what they will do? Go into the ring. Understand? So all these kids, yeah, they go into the ring again. So when this electron go into the ring, I can say that the charge density, okay, so the lone pair is the same story, delocalize into the ring. Understand? When lone pair delocalize into the ring, the charge density of your phenoxide ion decreases. And which means a phenoxide ion hardly attract back a H plus. Okay, here's the story, guys. What do you mean by formation is stable? I thought that all formation are stable. No, what do you mean by formation is stable? Formation is stable means that this fella is unreactive, or this phenoxide ion will hardly turn back. Understand? So when a phenoxide ion is formed, phenoxide ion will hardly react. Understand? Okay, so it can be formed as a product itself. Okay, so unstable product will always undergo another reaction to turn into something else. But phenoxide ion is stable, which means phenoxide ion can be found. Like when you throw phenol into water, right, you will get a phenoxide ion and also some phenol. Okay, so both are quite stable, but phenoxide ion is more stable. All right, now let me repeat the story again. This is quite difficult, but try to understand the concept. Don't memorize it. Memorize doesn't work. You have to understand. Don't memorize, please. If you are memorizing this entire theory, right, trust me, they will twist and turn, then you don't know what's going on again. First, you have to tell me why phenol is an acid. Why phenol is an acid? Because all these electrons, they will go into the ring. Understand? So remember, electrons are like kids. Right now, the theory is when you see electrons, you see them as tiny little kids. They love playground. So you see all these electrons, they're going to go into the ring, go into the ring. When they go into the ring, the OH bond is weakened. Okay, that this can be broken to turn into a H plus. That's the first thing. Okay, sometimes they will ask you, hey, why phenoxide ion is stable? That's the second question. Why phenoxide ion is stable? It's stable because the lone pair, the same story, go into the ring. So technically saying, guys, the negative charge, although when you draw it this way, but in actual, right, the negative charge is not there. Why? Because all the electron is already in the ring. So this thingy hardly go back. Okay, one more time. You draw it, yes, the lone pair is here, the negative charge is here. But in actual, the electron is never there already. Just like imagine that the house has, you stay under this house, there's 5 members. Okay, but when you visit the house, right, there's 0 member. Why? Because all these members, right, they go into the ring already. Understand? So technically saying, you walk into the house, although there's 5 members, but you see no one. Why? Because all these kids will go into the ring. When they go into the ring, the H plus will hardly go back. Understand? That's the story. Yes, yes. Teacher said that oxygen orbital. Now, this is the oxygen orbital. It overlaps with the pairing system. Basically, it's the electron that goes in. Yeah. So your teacher is right. Your oxygen orbital overlap with the pairing system. Now, it's basically the same. This is your oxygen orbital. So overlap with the pairing system. It will go into the ring. Okay, remember that, yeah? Okay, now let's go. Okay, second, why phenol is a weak acid? What do you mean by weak acid? You see, right, by right, a strong acid, it's one directional. Okay, but phenol is a weak acid, which means there is still a tendency for a phenoxide ion to combine with a H plus to turn back into a phenol. One more time, it's a weak acid, which means there is a tendency for phenoxide to combine with H plus, go back to turn into a phenol. How? So guys, why is it so? Because of oxygen. So let's look at oxygen. You see, right, this oxygen, it's highly electronegative. You get me? This oxygen, right, is a highly electronegative atom. Okay, so this highly electronegative atom, right? The story, just imagine it like a very strict Asian parents. I think it's Sujai's parent. Yeah, your parents kind of strict, right? GG, wait for your A-level result. Oh, strict Asian parents, yes. That's okay. So basically, these parents, right? You see, let's say if you Okay, this is your phenoxide ion. Hey, don't, I don't want this one too colorful. Okay, look at your phenoxide ion. You have a lone pair. Okay, then you have a H plus. Okay, so just imagine this is your mom basically. So if you go out to a playground, for example, right, you go out, have fun for hours and hours, eventually your parents gonna call you, be like, oi, it's time to come back. Okay, so this is what the oxygen does. The oxygen is like, enough nonsense, stop playing, I'm gonna summon you back. Understand? Because oxygen is highly electronegative. So even though the kids will go into the playground, but this oxygen, it's highly electronegative. It's like time to come back. So oxygen can also draw the electrons back. Understand? So the electrons, right? The movement of electron, you have to visualize it like that. You see, at first, you look at my arrow, yeah. So the arrow, all this kid, right? They be like, I want to have fun. Morning, go out, go out, go out, go into the ring, play, 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 play. Eventually, your parents drop you a call. It's time to come back. Okay, come back, come back, come back, come back, come back. Then they go back again. Okay, so this electron, right, is constantly looping around, you get me? It's constantly looping around, go into the ring, go back, go into the ring, go back. Okay, so when the electrons go back, then the H plus can be attracted. Understand? Clear. So the movement of electron is like that, yeah. Go into the ring first because they love playing. Then eventually oxygen will be like, it's time to come back. Then they'll go back. Understand? Okay, later I will write down the statement. So I want you guys to draw this first. At least you know how the movement of electrons be like in a phenol. All right, guys, now statement time. So you see, guys, oxygen is highly electronegative, which means a hydrogen plus, this hydrogen plus ion can go back to phenoxide ion. How? So thanks to the highly electronegative oxygen atom, so what they do, right, it draws back the electrons from the ring to your oxygen atom, and eventually your O minus and H plus will combine, reforming a phenol. Understand? So which is why it is just a weak acid. It's not a strong acid. Okay? There is a reverse reaction as well. Why? Because oxygen, highly electronegative, is able to draw back the electrons. Clear? Good. Done? Okay, so if good, let's move on to the note in page 1. Okay, so just now I did mention that your phenoxide ion is very stable. Okay, so why the phenoxide ion is very stable? Because all the lone pair would delocalize into the benzene ring, which reduces the charge density. Okay, so this delocalization reduces the charge density of the phenoxide ion, which make it more stable. Highlight the word delocalization, reduces the charge density, more stable. So does it mean reversible reaction like constant go backward and forward? You are right. Yes, correct. It's always going forward, backward, forward, backward, forward, backward. It's a reversible reaction. Why is it a reversible? The reversible reaction, the story is like the kids go into playground, got dragged back to home. Then go to playground again, then parents call them home. So to playground, go back, to playground, go back. It's always like that. So that's why it's a reversible reaction, okay? So in actual Tanvir, this is what your teacher mentioned, the overlap of the orbital. So in actual orbital, right, it does look something like that. You see all these lone pair? So they go into the ring. They go into the ring. Can see that? They combine into the ring, combine into the ring. That's it. Okay. So now, alternatively, we can explain the greater the acidity of phenol by saying that phenol ionized to form a phenoxide ion. Okay, so the ionization of phenol is more likely. Can I? Okay, so guys, this two story will explain why phenol is an acid and why is it a weak acid. Okay, so again, highlight the word oxygen is very electronegative. Delocalized electron will be drawn back. Remember, yeah? Hello, Mr. Chin, have to leave before me. Can, no problem, Amber. What time is it? What time is Edison's class? Okay, so that's why phenol is only a weak acid. Oh, okay. Okay, now let's continue. Comparing ethanol, water, and phenol, which one is more acidic? Explain. Okay, so this question is a combination of AS and A2. Okay, let's look at ethanol first. Let's remember how to draw ethanol. C2H5, OH, right? Guys, alright guys, now let's look at EDG. Guys, please tell me, what is EDG? Let's go. What it does? What EDG does? Alamak. Okay, so what EDG does? So I have AB. Okay, so is it correct to say as one of the lone pair or bond pair? No, it's okay. We just say lone pair. Don't need to say bond pair. Why is charge density reduces? I thought it's becoming high in the ring. No. Okay, so I have a kid have this question. Why the charge density decreases? Because the charge go into the ring, what? The negative go into the ring. Understand? So it's the charge density decreases. So also, if it is a strong acid, does it mean H plus is never attracted back? Yes. You see the bonding pair between, yes, correct. So basically the bonding pair, right? Okay, so the bonding pair never really go into the ring. It does, but it's just moving around like that. It's mainly the lone pair that go in. The bonding pair will go here. So the bonding pair go here, then the lone pair go back. It's like that. So this one go here, this one go back. So in exam, usually we just write lone pair go into the ring. We never write bonding pair. Okay, so we always write the lone pair of oxygen go into the ring. Okay, I hope. So guys, now let's continue. So kid, let's look at your EDG. Again, for EDG, what it does, we call alkyl group as alkyl group is an EDG, right? Electron donating group, right? All right, guys, please tell me what EDG does. EDG, they push the electron towards where? So you see, they are known as electron donating alkyl group, which means they're gonna push the electron towards your O and H. Get me? Okay, so they're gonna push all the electrons towards here. Clear. So it pushes the electron towards O and H. Understand? So guys, I'm gonna give you a diagram. You see this? You have a C2H5. Okay, then you have a phenoxide ion. Let's say, right, so this is a phenoxide ion. This is a minus, put it as minus. So you see, right, this EDG, what it does? It pushes the electron towards the oxygen. Understand? So which means, what about the charge density? The charge density is gonna go up. Okay, so the charge density increases, which means, let's say if you put a H plus here, right? H plus is 100% going back into the ethoxide ion. By the way, this we call it as an ethoxide ion. Yeah. Understand? One more time, guys. You see, you have electron donating group. Okay, so electron donating, it pushes the electron towards your oxygen, which means this negative, right, is highly negative. Correct? You have a lot of electrons here. So the charge density is very high. So immediately will attract back a H plus. Okay. So I can mention that, right? The charge density of your ethoxide ion increases, which also means that your H plus is easily attracted back. Am I right? Okay, so remember this. When you have an EDG present, EDG always strengthen your OH bonding, which means it makes a weaker acid. Highlight this word, EDG, strengthen OH bonding will always make a weaker acid. Understand the concept? Ethoxide ion after the electron push or before push. Ethoxide ion is ethoxide ion has nothing to do with electrons being pushed before or after. Ethoxide ion is when this thingy breaks. When this thingy breaks, that we call it as ethoxide ion. Okay. So even before or after the electrons being pushed towards the oxygen, it's still an ethoxide ion. Okay, so it doesn't have to do with before and after. So again, ethoxide ion is when OH break, then you get an ethoxide ion. Okay, so even before an ethoxide ion is formed, your EDG is already pushing your electrons towards the O and H, which means the O and H here, right? This bond is very hard to be broken. Understand? It's very hard to be broken at the first place. Okay, even if it's broken, this is even if it is broken, it will immediately attract back a H plus. Understand? One more time. So EDG pushes the electron towards your OH before it is even broken. So the EOH bonding here, right, is very strong. Okay, in fact, right, it's never broken. Understand? It's 90% never broken. If the 10% of the time it breaks, immediately it's reformed. Why? Because the charge density here is super high. Even if it's broken, immediately a H plus will go back. Clear? So which means this thingy is never acid. Remember, ethanol is never acid.
Sir,
Yes.
then why do you write weaker acid then?
Oh, because usually they will ask you to compare the acidity. So this is the weaker acid.
Okay.
Yes, Abby, the question that you asked, strong acid means H plus never attracted back is true. Okay, guys, remember alcohol is never acidic. pH of alcohol is 7. That's that. Alcohol is not acid at all. Okay, sometimes it's even greater than 7. Okay, guys, now water, let's not talk about water. Let's talk about phenol. All right, guys, you guys gonna tell me what's gonna happen for phenol, So guys, the story of phenol, how it occur, the lone pair will go into the, I just want you guys to draw one lone pair or else it's gonna be very messy. Just one lone pair will do, one lone pair. You highlight the lone pair and draw an arrow to indicate that it's going into the ring. Okay, so instead of drawing your orbital like that, then draw another orbital, it's okay. You just highlight the lone pair, go into the ring, that's it. That's the story. Okay. How do you know which one's Sorry? How do you know what? Okay, in your entire syllabus, EDG, LQ, or the CH3, C2H5, C3H7, they are always an EDG. Understand? Okay, so remember EDG is always LQ group. Methyl, ethyl, propyl, butyl, those are EDG. Okay? So clear your EDG. Second thing that we have is the playground. Remember, guys, now every time you look at the benzene, Remember this, benzene will always have an electron playground. One more time, benzene will always have this electron playground. So what's going to happen? Please tell me now. The lone pair on your oxygen, how? So the lone pair on oxygen atom overlap with the delocalized pi ring system, right? So guys, this entire line is telling you the electrons go into the ring. But in exam, you cannot write it as the electron goes into the ring because it's not scientific, it's not chemistry. So you have to use this professional keyword, overlaps with the delocalized pi ring system, or delocalize into the ring. Keyword delocalize and keyword ring. Understand? Please, don't just say electrons go into the ring. No marks awarded. Keyword is delocalize. Okay? Okay, guys, once the electron go into the ring, what happens to the OH bonding? Yes, correct. Thank you very much. Second point, please write it as your OH bonding is weakened.
So,
Guys, when OH bonding is weakened, is it easier to break or harder to break? Yes, well done. It's easier to break.
so the pi ring system is delocalized.
Sorry, come again?
The pi ring system is delocalized.
Yes, because the electron is always moving around in the ring.
Okay.
As without the electrons coming in from oxygen, right? The electron in the ring is always moving around. Understand? They are always moving around like that.
Thank you.
Okay. So right now, OH is easier to break. Yeah. Understand? So which make it acidic, right? Understand? Okay. Now let's talk about. We are done talking about this one. Let's talk about after it is being broken. Yeah. So right now, what do we have? It's a phenoxide ion. You see a phenoxide ion. Deng, deng, deng. Phenoxide ion. Alright, guys, remember this. When a phenoxide ion is formed, it's very stable. You can mention that your formation of phenoxide ion is stable. Okay, what do you mean by stable? Why? Because the charge density on your phenoxide ion is reduced, right? Which means the H plus hardly attracted back to phenol, right?
So the charge density decreases because the electrons from the oxygen have gone to the pi ring system, right?
Yes, you are right. You are right. You are right. Why the charge density decreases? Because the electron here go into the ring. Yes, well done. It's physically go into the ring. Yes, but oxygen will summon it back. So oxygen will lose it, but will summon it back. Why? Because oxygen is highly electronegative. So they lose. Then after all the electron is gone, right? They'll be like, okay, it's time to call back. Then they will call back. So it's always moving around. You are right. So basically, right, you can just imagine the movement of electron, right? It does look like this thing. Okay, will always like that. Will always be like that. The electron move in, then go out, then move in again. It's always like that. It's always revolving like that. Understand? Okay, so remember this, guys. In right now, in A levels, electron is never fixed at one place. Electron is always constantly moving around one. Understand? Electron is like planet. You don't see your planet stuck at one place, right? It's always revolving around the sun, right? The same thing happens for your electrons. I draw it here doesn't mean that it's physically fixed there. Okay, it's not. It's always moving around. Understand? It's like dang, then go in, go out, go in, go out, like that. Okay, please. So guys, remember, right now, whenever you see a benzene ring, okay, will strengthen an acid. Why my A looks so gay, bro? Okay, so remember, a benzene ring will always strengthen an acid. Okay, An EDG will weaken an acid, but benzene ring will strengthen an acid. Understand? Let me tell you, this type of question, right? It's 100% coming out. 100% coming out in your P4 for 3 to 4 marks. It's 100% coming out. Okay, so it's either acidity or basicity. Okay, so and you will either get a phenol or carboxylic acid or SU chloride, you have more. So please understand the concept, don't memorize it. Alright, so guys, to summarize, ethanol is the weakest acid. In fact, ethanol pH is greater than 7. Okay, and water and phenol. So this is my answer. So in exam, you really have to arrange like that one, they will give you different compound, then you have to arrange and also explain on the reason why. Okay, so phenol is the strongest acid.
So just checking one last time.
Yes, come.
The benzene ring strengthens the acid because it reduces the charge density on oxygen, which reduces the chance of the H plus ion coming back, which does not decrease the concentration of H plus in solution.
Which does not decrease the concentration of H plus in solution. Yes, correct. Yeah, you are right.
Okay, thank you.
But you don't have to mention about the concentration of H plus in the solution.
Yeah.
You just have to, well, but your concept is not wrong. So again, what Tanvir mentioned, right? Yes, it's correct. So the lone pair on your oxygen go into the ring, which means the negative, despite you drawing it there, but physically it's not there. So H plus hardly go back. Okay, that's it. Okay. I don't understand it's okay. The concentration, you don't care. You don't need to care about the concentration. Okay, I never talk about the concentration. The concentration of H plus, we're gonna do it if ionic equilibrium. At this level, you just need to know, guys, very simple. What makes a very strong acid? If OH bond is easily broken, is it strong acid or weak acid? Strong acid. Well done. If OH bond is very hard to be broken, weak acid. That's it. That's the theory. Okay, one more time. If you have a strong OH bond, weak acid. You see that? This OH bond is very hard to be broken. Why? Because you have EDG keep on supplying your electrons here. So it's very hard to be broken. Weaker acid. Understand? Whereas, let's look at phenol. This OH is easily broken. Why? Because the electron, all the electrons go into the ring already, right? So the OH bond is weakened. That's it. Okay, that's the knowledge that you need. Concentration of H plus, don't care first. We're going to talk about it later on. Okay? Clear? Yes. Yes, you're right. EDG increases the charge density. You're right. Yes, that's why the OH bond is stronger. All right, guys, now. Ethanol is a weaker acid than water. Why? Okay, because you have the presence of EDG, right? Okay, so you can write it down, the presence of EDG. Okay, I'm gonna use short form, yeah. EDG stands for electron donating group, yeah. Okay. So again, when you have EDG, guys, tell me the answer. Increases charge density or decreases charge density? Test your understanding. Increases the charge density, right? Correct. Thus, making it a weaker acid, right? Yes, thank you very much. Okay, guys, this one, okay, it's just put it there as extra knowledge because we're not gonna apply this knowledge in this chapter, but next chapter we're gonna use it. So, guys, we are done talking about EDG. So we have another opposing group, right? We call it electron withdrawing group. Okay, so electron withdrawing group, it's in A2. Okay, the next chapter we're gonna deal with electron withdrawing group. Is everything opposite of an EDG. So again, guys, EDG will decrease an acid strength. What about EWG? Increases, yes, strengthen. So increases I want you guys to highlight this. When you have EWG, strengthen the acid. EDG weakens the acid. Understand? Correct. It lowers the charge, or it's stealing all the electrons here. So when it's stealing the electron, this bond is easily broken. Then stronger acid. Okay? Can I? Okay, so an hour is gone. We done 3 pages. Very productive. Yeah. Alright. Now, okay, after this, no more concept. After this, pure memorizing, because you're gonna memorize all the reaction already. Let's go. Okay, so guys, understanding is over, yeah. Okay, these are all the understanding. Do not memorize page 1 to 3, yeah. Page 1 to 3 is supposed to be understanding. Memorizing comes in here. This is your memorizing part. Okay, so you memorize from here. Okay, front part, understanding, memorizing doesn't work, yeah, guys. Do not memorize why. Understand why. Don't memorize, okay? Okay, I don't want you guys to memorize, please, page 1 to 3, you're not supposed to memorize. You're supposed to understand, then you can tell the story. Go and tell a story, okay? Now it's memorizing. Everything is memorizing now. All right, guys, first, how can you prepare a phenol, right? It's by adding phenylamine with HNO2 or NaNO2 under dilute HCl. Okay, and you have to do it under 10 degree. Yeah. Alright, guys, by the way, let's look at your HNO2. It's not a typo. It's supposed to be HNO2. Okay? Don't write it as HNO3. This is not a nitric acid. This is known as a nitrous acid. Understand? Okay, it's not HNO3. It's HNO2. Nitrous acid. Alright, guys, now. So a production of phenol can be explained with few steps. The first step is a production of a diazonium salt, and second step is to warm a diazonium salt with water. Ding, ding. Okay, first step, we can make the nitrous acid by using a sodium nitrite and dilute HCl. So guys, first step, equation, you have to memorize. NaNO2 plus a HCl will turn into a nitrous acid, HNO2 plus NaCl. That is your nitrous acid. That's your first step. Okay, guys, once your first step is done, second step in the synthesis of a dye, okay, so what you need to do, right, you have to form this benzene diazonium salt. Okay, so what I'm gonna do, I'm gonna take a phenylamine and I add HNO2, I add HCl acid, and this reaction has to be carried out below 10 degrees Celsius, and eventually it's gonna turn into a benzene diazonium chloride and triple bond N Cl plus H2O12. Please write this down. Guys, for your info, this part is damn important. Go and, okay, so please write it down. Okay, once your first step is done, guys, okay, after that, okay, is to form a phenol. So how do you form a phenol, right? Is by warming it. Okay, so I have to warm it. Highlight, warm with water to produce a phenol. Okay, guys, now let me repeat that. You see, your first step is to get HNO2. Can see that? Second step, show your HNO2 here with a phenylamine. Then you get this ding ding. Once you get this ding ding, we're gonna take this ding ding and we're gonna heat it or warm it under H2O. So I'm gonna take this entire ding ding. I'm gonna heat it under H2O. Okay, so when you warm it with H2O, this N ding ding, right, will be broken and eventually it turns into a phenol. Okay, so this N will turn into an N2 and HCl is formed. Understand? So this is a step by step reaction. Clear? Can up some more. Can done. You are supposed to memorize this reaction. This reaction has about 30 to 40% coming out in the exam. 30 to 40%. Yeah, quite important. Yeah, you must know how to draw. So our teacher don't teach this part. Means your teacher miss out. Yeah. This is a new syllabus introduced after 2022. Yeah. So guys, this part is a new syllabus only after 2022 is being introduced, which means already 3 years, not considered new. No? Sorry? Yeah, will be. Usually they will be. Yeah. So what's the mechanism for this reaction? Do we have to know? Luckily, the mechanism you don't have to know. You did something to your hair. Why your hair look a bit different? I don't know. It's like wavy now. It's always the wavy man, no, right? Okay, so yeah, no, the mechanism you don't have to know. Yes. So you just have to know how to draw it. You don't have to know the mechanism behind. Okay. So guys, let's build it up. Okay, so first, guys, what do we need? We definitely need a phenylamine. Kid, this is a phenylamine. This thing NH2, NH2. NH2. This is a 2, it's a phenylamine, understand? So I need a phenylamine and I need a NaNO2 plus HCl to turn into a HNO2. Understand? So I need NaNO2 plus HCl, or I can straight away introduce a nitrous acid. Okay, so that is the reactant. So there's two different steps. The first step, we have to do it below 10 degrees first. The second step, then we have to warm with H2O. Clear? Okay, guys, first, we have a phenylamine plus a HNO2. You do it below 10 degrees, and you will get a diazonium salt. You warm it, turn into phenol. Okay, by the way, this just being introduced into your syllabus in after 2022. Yeah, after 2022, which is considered still quite new. Any past year before 2022 will not have this question. Okay. So mechanism, diazotization. Mechanism, you don't need to know how to draw it. Good thing. Okay, so there's no need for you to know how to draw the mechanism. But you need to know a reaction, yeah. Equation you need to know. Clear. Okay, page 29, page 5. Wait, what did you say didn't and do not need to know? This entire reaction, you need to know how to write it. But the mechanism, no. You don't have to know how to draw the curly arrow, this and that. No, there's no curly arrow for this reaction. Okay. All right, now let's look at the reaction of phenol. So guys, you see, okay, let's look at the reaction of phenol. This also why you need to know why. Okay, so first, guys, let's look at OH group. Okay, kid, let me ask you a question. Phenol is more reactive or less reactive compared to a benzene? Okay, so first, let's look at the benzene now. Okay, I want you guys to look at the board. You don't have to do anything. Try to understand it. Okay, so guys, comparing phenol and a benzene, which one has more electrons in the ring? Please tell me. Which one has more electrons in the ring comparing a benzene and a phenol? Phenol. Why? Because oxygen. Yes, well done. Yes, you got it right. Because oxygen, lone pair go into the ring. Okay, so don't draw anything. Later I will give you the proper answer. So first thing you need to know is phenol has more electrons in the ring compared to a benzene. Understand? So guys, let's say if I put a nuclear electrophile, I put an electrophile which is a Br plus. So Br plus, right, will be attracted to phenol more or benzene more? Phenol more. Yeah, well done. Why is it attracted to phenol more? More electrons. Good job. Yes, well done. You got it right. So guys, phenol is more reactive than benzene. Over one reason. It has more electrons in the ring, which the electron density is higher. So it's going to attract electrophile even more. Understand? Clear? Okay, I have two chat coming in. What is this? Phenol. Phenol, thank you. Alright, so guys, look at this. The OH group attracted or attached to the benzene ring will make the ring more reactive. Remember, the ring is more reactive now. Why? Guys, remember phenol is more reactive here on one reason. Lone pair overlap with the pi bond system, right? Am I right? So what it's going to do? It's going to increase the electron density. It's going to increase the electron density of benzene ring. Understand? Clear? So right now, benzene has a lot of electrons in it. So highlight benzene, when a reaction happens, right, the ring is always attacked by an electrophile. So which means right now it's becoming even more attractive to an electrophile. Understand? Clear? Okay, and guys, the final part, OH group, a phenol has a 2,4 directing effect. Which means any substitution on a phenol, it's always going into the second or the fourth position. Understand? Clear? Okay, so if you understand the story, you don't need to memorize anything. Try to understand the concept. Don't memorize. Memorize doesn't work, guys. You're supposed to understand how the electrons go. Okay, instead of memorizing a phenol is more reactive. No, don't memorize, because in the exam they really will twist and turn the question until I don't know how. Can you explain why OH has 2,4 directing effect? There's no explanation. The para explanation, it's way beyond your syllabus. You don't need to know. Yeah, so the explanation on why is it 2,4, no need to know. You have to memorize that it has a 2,4. Metal also, okay? So all this 2,4 directing, 1,3,5 directing, you have to memorize, yeah. Okay, guys, now let's look at the first reaction we have with sodium hydroxide. So, guys, phenol is an acid. Remember, phenol is a weak acid. If I throw it with NaOH, a base, what type of reaction is going to happen? Acid plus a base? Neutralisation. Thank you very much. Remember, neutralisation reaction is going to happen. Well done. So, guys, when the neutralisation reaction happens, what is formed? Salt and water, right? Good job. So, guys, the salt being formed, right, is this Na is going to replace the H. Okay. So, this thing turn into a O and A and a H2O. To balance the equation, you have two. No, it's already balanced. Understand? So, guys, the salt form has a name given. We call it as sodium phenoxide. Okay, all good. So, guys, reactant, I need a phenol. I'm going to add it into an alkaline. Any alkaline will do. Okay, so condition room temperature. Why? Because phenol is very reactive. And reaction-wise, I get a phenol and I add an alkaline. Ding, ding, ding. I'm getting a salt and H2O. Understand? Clear? Good. Please write down. Give me a second. Let me mark attendance. No. You just said phenol is stable. Hello. Since when I say phenol is stable? Since when I say phenol is stable? Yes, I say phenoxide ion is stable. Oh, don't twist my word. I say phenoxide. I never say phenol is stable. I say phenol is weak acid. Oh, putting words in my mouth now lah. Hiya. Phenoxide is stable. Phenol is weak acid. Understand? Please
Phenol that only because it's weak as only because it can lose and disassociate.
Yes, it can lose the H plus. You are right.
So phenoxide ion is also can
Phenoxide ion, no. Phenoxide ion is stable. So when the phenoxide ion is formed, the phenoxide ion will just stay there. Su An is here, Mevin is here, Junxuan is here, Junxuan is. But I thought in neutralisation, yeah, neutralisation has to be a phenoxide ion. You see, your phenoxide ion never react, turn into something else, right? Your phenoxide ion stay there. What do you mean? Understand? Phenol is not stable. Phenol is reactive. Phenoxide ion form already. You see, your phenoxide ion got any other reaction or not? No, stay as a phenoxide ion, what? Right? Can see that?
in phenoxide ion don't just go back into the benzene.
Yeah, it does. So the same thing happened. Go into benzene ring, then go back, go into benzene ring, go back. It's bonding with sodium. Yeah, it's bonding with sodium because of the O minus one, O minus and E plus. Okay. Okay, guys, now let's continue.
Sir. When we
Yes,
say
yes.
when we say phenoxide, we are referring to the ion, right?
Yes, phenoxide, we are referring to the ion. The O minus is known as a phenoxide.
Thank you.
Alright, guys, now let's look at the second reaction with a metallic sodium. Highlight the word react vigorously with a metal reactive matter to give hydrogen gas. Phenol plus a sodium metal will also turn into a phenoxide ion. And a H plus is H2 is produced. To balance the equation, 2 phenol, 2 sodium, 2 phenoxide ion. Alright guys, I have a question. Anyone can tell me what type of reaction is this? It's a metal plus acid. Yeah, but there's a name given. I give you a hint. Start with D. Anyone? When something being kicked out by... Yes, thank you very much. This is a displacement reaction. Who got it right? What displacement? What displacement? What baby, not dehydration. Dehydration, please, guys, please tell me what's the definition of dehydration? No water. You're not removing water. There's no H2O. You get me? Okay, it's just H is being replaced or displaced by a sodium. It's not dehydration. Dehydration is removing H2O. Okay, but good try. Okay, remember that. It's not. Sir, my teacher say it's redox. Okay, your teacher say it's redox. Your redox reaction is also okay. Displacement reaction is a type of redox reaction. Your teacher is not wrong. It's redox reaction. Displacement is a redox reaction. Why? Guys, why? Oxidation number here? 0. Oxidation number here? +1. Sodium undergo? Oxidation. Correct. Hydrogen here? +1. Hydrogen here? 0. Undergo reduction. Okay, so this is also considered a redox reaction. Yes, it's not wrong. It's redox reaction, but displacement reaction is a type of redox reaction. So I will put it as displacement. If you put redox, it's okay. Okay, so it's like that. This is redox. Displacement is under redox. So displacement is a type of redox reaction. Okay, so all displacement reaction are redox. All redox reaction are not displacement reaction. Okay, subset, superset. Thank you very much. Alright guys, reactant. Phenol plus sodium. Condition, I just have to put it under room temperature. Reaction, phenol plus sodium. Ding dong kang chang, you get a salt plus H2. Understand?
You don't need like reactions involving the NASA.
No,
How
just how is it formed? Yeah. In fact, phenoxide ion will hardly have any reaction. On one reason, phenoxide ion is stable. Okay, so guys, phenoxide ion hardly has any reaction because phenoxide ion is stable. Understand? Alright guys, next we have bromination of phenol. Alright guys, now let's look at last week. Before, because you need to know the comparison between the bromination of benzene and bromination of phenol. Okay, let's look at your bromination of benzene first. Alright guys, you see, for bromination with benzene, okay, just a benzene, you need a catalyst, correct? You need a catalyst. Why? A catalyst is required to produce an electrophile. Remember, a bromination of benzene. You see, a benzene turn into a bromobenzene. You need a catalyst. But bromination of phenol, there's no requirement of a catalyst. You don't need a catalyst. Why? Because phenol is more reactive. Remember, yeah? So highlight the word. Okay, so write down bromine react very vigorously with phenol under room temperature. There is no need for a catalyst. No, you don't need a catalyst. Why? Phenol is more reactive. Okay, so you will get a white PPT of 2,4,6-tribromophenol and a white film of HBr. So highlight the word white PPT and white fumes. Okay, alright guys, I have a phenol. I'm gonna add 3Pr2. Don't even need to add anything else. Just throw them together. They will start reacting already. On one reason, phenol is very reactive. And boom, and boom, and boom. 3 HBr. Okay, so that's your 2,4,6-tribromophenol. Okay. Alright guys, now I have a question. I want you guys to tell me what is the mechanism behind. Anyone? Well done. Electrophilic substitution. Guys, remember this. Anytime and every time you are substituting, does the position of bromine matter? Yes, it does matter. Okay, so again, guys, anytime a substitution occurs on the ring, it's always electrophilic substitution. And guys, remember this, yeah? The position, electrophilic, the position of your Br matters. If you draw a 3-5, it's considered wrong. Okay? Why? Phenol has a 2,4 directing effect.
When you get 2.6 when it's excess of bromine.
No. With it, it will automatically forms a 2,4,6. Why? Because it's very reactive. Okay, remember it's very reactive. It will automatically forms a 2,4,6.
But in some cases it said it was 2 and 4.
Okay, 2 and 4, 2, 4. That happens when it is a benzene. Now you see, a benzene is different. So a benzene is just one position. Can see that? It's just one position, unless it is excess. That's benzene. But phenol is always a tribromo. Understand? Phenol is always a tribromophenol, yeah? Okay. Okay, guys, next, nitration of phenol. Okay, so guys, phenol can react with a dilute HNO3, dilute nitric acid at room temperature. Highlight the word dilute, room temperature. Okay, this time, what a phenol's gonna form? A phenol gonna form. Again, guys, phenol, it's always position 2 and position 4 directing. So this one, right, will form a mixture already. Okay, so this no longer will get 2,4,6. Will be a mixture first. You get either a 2 nitro or a 4 nitro phenol. Understand? Okay, so you get a mixture of product. It's either a 2 nitro or a 4 nitro phenol. Clear? Again, position matters. It will always go into 2,4 position. Okay. Alright, guys. Let's say if we use concentrated, then it's a different story right now. Guys, if you use concentrated, what do you get? Gas. 2,4,6 tri. How do you get? Oh wait, never mind. So if you use a concentrated, guys, this time you will get 2,4,6 trinitrophenol. Alright guys, now wrap it up. We have phenol plus HNO3. Condition again, it's room temperature, yeah. But the condition, right? Okay, why you call it 2,4,6? But for bromination, you call 2,4. I call 2,4 only, man. 2,4,6 what? No, since when I call 2,4. Bromination also 2,4,6 what? 2,4,6. Is it your mistake? It's your mistake, not my mistake. Bruh. Hiya. Okay, so let's look at dilute HNO3. If you use a dilute HNO3, right, guys, what do you get? You either get a 2 nitro and a 4 nitro, right? Correct. But guys, if you use concentrated, how? Correct, you get 2,4,6.
I don't get dinitro.
No. Dinitro, not really. Yeah. Okay, 2,4,6 trinitro. Electrophilic substitution. Okay, I have this question. Someone said, sure, you said OH has 2,4 directing effect. Why is it 2,4,6? Anyone can explain to this kid? Cho said, so Cho is wrong because Cho said 2,4 directing effect, but you draw 2,4,6. Why? Why? So guys, what is position 6? Your position 6 is the same as position 2. You can go clockwise, it's position 6. Anti-clockwise is position 2. Understand? 2 and 6 are the same because you can go clockwise, anti-clockwise. Okay? Please like and subscribe. So someone can take it. Please like and subscribe.